Compute the limit. Let's say that you are given this limit as it approaches negative infinity for radical 4x squared minus 8 divided by 6 plus 4x plus 9x squared. To solve this problem, the first thing you need to do is to isolate the leading term for the numerator and the denominator. The leading term is the same thing as the highest degree for the numerator and the denominator. So in this particular case, the numerator's highest degree is the x squared. So you need to isolate this x squared from the numerator. So it will become, so you write equals to limit as it approaches negative infinity. So to isolate the numerator as leading term, which is the highest degree, you write out the x squared times 4, because x squared times 4 is the same thing as the given of 4x squared. Minus stays the same, 8 divided by x squared. X squared can cancel with this leading term of x squared, and you're left with the negative 8, which is the same thing as the given of negative 8. And you do the same thing for the denominator. You isolate the highest term for the denominator, which is x squared. Put a parenthesis, 6 divided by x squared, because x squared divided by x squared right here cancels out, and you're left with the 6, which is the same thing as the given. I mean, the whole concept behind this isolations of the leading term is to make it look like the given by dividing it by the leading term. So you plus 4x divided by x squared. X squared cancel with this x squared, and you're left with the 4x, which is equivalent to the given, plus 9 times x squared is the same thing as the given of 9x squared. So once you isolate the leading term, the point of isolating the leading term is that at the end you could cancel it. That's the whole concept of why you need to isolate the leading term. So once you have this multiplication out, the next thing is to separate the leading term from this expression right here. So radical x squared times 4 minus 8 divided by x squared, you can actually separate the radical x squared out of it. So it will be like this. As for the denominator, it will stay the same. Once you do that, you can see right here that you can actually cancel out the leading term from the numerator to the denominator. But before you do that, you need to do an extra step for the numerator. You need to take the radical of x squared. Recall that x squared recall that square roots are always positive. So you need to put a absolute value bars on the x to make sure that it is positive. So radical x squared becomes x, but you need to put a absolute value bar next to it to make sure that it's positive. So it would be like this times this expression divided by the expressions of the denominator. Once you have that, you can actually take the limit as it approaches infinity for this expression. But before you do that, you need to get rid of the absolute value bar right here. So it will be, as you take the limit as it approaches infinity for this absolute value of x, it will be, absolute value of x will be x, right? But as you take the limit as it approaches negative infinity for the x, it will become negative x times this expression, and the denominator stays the same. Once you have that, this x can cancel out with it, can divide it by x squared. So on the numerator, it will be 1 minus 2 for the denominator. So x1 minus 2 will be negative 1. To get rid of the negative exponent, you put it on the denominator to make it positive. So it will be like this. And as you take the limit as it approaches negative infinity for radical 4, it will stay radical 4, negative radical 4, because anytime you take a limit as it approaches infinity for a constant number, it will be that particular constant number. And as for this fraction right here, as you take the limit as it approaches negative infinity for this fraction, it will reach 0, because if you take 8 divided by a very large number, it will reach 0. It's the same concept for this one and this one. So on the numerator, it will be negative radical 4, because as you take the limit as it approaches infinity for a constant number, it will be that particular number. As for the denominator, as you take the limit as it approaches negative infinity for a variable, it will reach negative infinity. And the 9 will be 9, because as you take the limit as it approaches infinity for any constant number, it will be that particular number. So radical 4 will become negative 2 divided by negative infinity times 9, which is negative infinity, and negative 2 divided by a negative infinity, it will reach 0. Because 2 divided by a very large number, it will eventually reach 0. And a negative divided by a negative will be positive.